Okay, so we are going to look at what an expression is and how to simplify it, because that is our learning objective for today. So first of all, an expression is numbers, symbols, and operators that are grouped together. And so what that means is it does not have an equal sign. We are going to be working with equations a lot during this unit, but we're not going to do that yet. So everything we're going to be working with today does not have an equal sign. So something like 2x squared plus 3x minus 9 equals 0, that's an example of an equation. What we are going to be doing is working with things that look very similar. It's still going to have variables and numbers and operators, just no equal sign. So with expressions, there's some vocabulary that you need to know. There's really 3 words, okay? 3 terms. The first vocabulary term is actually the word term. So the terms are how many parts there are in an expression. So this one right here has got 3 terms. The terms, you can always tell by a term, is they're separated by plus and minus signs. So if you look at this, 2x squared is one term, minus 3x or negative 3x is another term, and minus 9 or negative 9 is the third term. You notice that the minus signs kind of get attached to the number that follows them. That's always going to be the case. And if that was like a plus 3x, then the second term would be a positive 3x, or you could say plus 3x. All right, the second vocabulary word that you need to know is what a constant is. So in this expression, of those 3 terms, the first 2 have variables. They both have an x in them. The last term does not have a variable. It's just a plain old number. And so plain old numbers in algebra, we call them constant, because no matter what x equals, that last term is always going to equal negative 9 or minus 9. That's why we call it constant. And then lastly is this term coefficient. So the terms that are not constant, okay, so the first 2, they have 2 parts to them. They have a number and then they have a variable. So in that first term, the number is 2 and then the variable is x squared. So the number part of that is what we call the coefficient. In the second term, we have a minus 3 is the first part and an x is the second part. So that first part is the coefficient, minus 3. What it means when you have a coefficient, like right next to a variable like that, what you're actually doing is multiplying those 2 things together. And so in this problem, I'm actually multiplying 2 and x squared. So I'm going to ask you a couple of questions about this algebraic expression. All right, hopefully you got those. Now, what do we do with algebraic expressions? There's no equal sign in them. So what we do is we actually go through and what we do is we simplify them. Algebraic expressions pop up in a lot of different areas in algebra, and a lot of times you want to make them easier to use. And usually that involves kind of making them smaller so that you can do more things with them in less time. So when we are simplifying an expression, if there's brackets, usually what we're going to do is eliminate those brackets. We're not really going to do that today. We're going to focus on that more the next class, but that is one of the steps that is typically involved with simplifying. What we're going to focus on today is combining like terms. That's probably the most important part when you're simplifying an expression. So if I've got an algebraic expression like this, 3x plus 8 minus 4y plus x minus 2y plus 1. That's an expression. There's no equal signs. I've got numbers and symbols in there and operators, but that is not simplified. If you look at this, if you look at the first and the fourth term, 3x and plus x, those are considered like terms. They're considered like terms because they have the same variable, and if there was, they both have the same exponent. In this case, the exponent is just the number 1. But if they have the same variables and the same exponents, they're considered like terms. Those aren't the only like terms in this problem. I could also look at minus 4y and minus 2y. Those are like terms. And you could also look at the constants. So in this problem, plus 8 and plus 1. Those are like terms. So if I wanted to take this right here and simplify it, okay, I need to combine all of those like terms. So to start with, if I've got 3x's and 1x, and I put those together, that's going to give me 4x. Then if I look at the y's, I have minus 4y and minus 2y. So altogether, I've got minus 6y. And lastly, if you look at your constants, plus 1 and plus 8, I put those together, that gives me a plus 9. So that expression right there, 4x minus 6y plus 9, is equivalent or the same as the first expression. It's just been simplified down. So those two are actually equal to each other, just one is in a little simpler version than the other one. One thing that's worth noting here, we talked about what a coefficient was, but beware of the hidden coefficient. And what I mean by that is in this problem, that plus x, there's actually a coefficient there. We don't see it, but that means that we have 1x. So anytime you've got a variable by itself, that means the coefficient is the number 1. That's why when I combined 3x and x and I put those together, it gave me 4x. So just in algebra, we don't normally put that 1 there. If you put it there, it's not wrong, but that is, that's what I mean by the hidden coefficient. What terms can be combined and which can't? 2x and 3x can be combined. They're like terms. If you wrote it out, we call this the expanded version. 2x means I've got 2 x's, and 3x means I've got 3 x's. So when you write it out like that, I could ask, well, how many x's do I have altogether? Well, I've got 5 x's altogether. But what if those variables weren't the same? Like, say I had 2x and 3y. Well, I would have 2 x's and I would have 3 y's. That's like having 2 apples and 3 bananas. I can't put those things together. Like I guess I could smush the apple and banana together, but if I'm trying to keep them as distinct, I can't. And so 2x plus 3y is already simplified. But what about if I was going to multiply? Could I do that? Like I've got a 2, which doesn't have a variable, and I've got a 3y, which does have a variable. So if I was going to do 2 plus 3y, I couldn't add those together because they aren't like terms. But what about multiplying? Well, multiplying means I'm grouping. So 2 times 3y means I've actually got 2 groups of 3y. Well, if I wrote that in expanded form, I would have 3y's plus 3 more y's, which gives me 6y's. So actually 2 times 3y can be simplified. I can combine those two things even though they aren't like terms. Because when you're multiplying, what you're doing is grouping as opposed to when you're adding and subtracting. It's kind of similar when we divide. Suppose I had 10 x's and I want to divide that by 2. Well, the expanded version looks like this. I've got 10 x's, and when you divide by 2, what that means is you're going to take whatever you have and you're going to break it into 2 groups. And the answer is how many things are in each group. So in this case, if I have 10 x's and I divide them into 2 different groups, how many things are in each group? Well, there's 5 x's in each group. So you can see 10x divided by 2 does simplify down to give me 5x. So in your assignment today, you are going to be solving problems that involve simplifying algebraic expressions.